A teleprinter is an electromechanical typewriter that can be used to send and receive typed messages from point to point and point to multipoint over various types of communications channels. They were adapted to provide a user interface to early mainframe computers and minicomputers, sending typed data to the computer and printing the response. Some models could also be used to create punch tape for data storage and to read back such tape for local printing or transmission. Teleprinters could use a variety of different communication media. These included a simple pair of wires, dedicated non-switched telephone circuits, switched networks that operated similarly to the public telephone network, and radio and microwave links. A teleprinter attached to a modem could also communicate through standard switched public telephone lines. This latter configuration was often used to connect teleprinters to remote computers, particularly in time-sharing environments. Teleprinters have largely been replaced by fully electronic computer terminals which usually use a computer monitor instead of a printer. Teleprinters are still widely used in the aviation industry, and variations called telecommunications devices for the deaf are used by the hearing impaired for typed communications over ordinary telephone lines. History: the teleprinter evolved through a series of inventions by a number of engineers, including Royal Owl House, David Edward Hughes, Emil Baudot, Donald Murray, Charles Elcrum, Edward Kleinschmidt and Frederick G. Creed. Teleprinters were invented in order to send and receive messages without the need for operators trained in the use of Morse code. A system of two teleprinters, with one operator trained to use a typewriter, replaced two trained Morse code operators. The teleprinter system improved message speed and delivery time, making it possible for messages to be flashed across a country with little manual intervention. By 1846, the Morse telegraph service was operational between Washington, D.C., and New York. Royal Owl House patented his printing telegraph that same year. He linked two 28-key piano-style keyboards by wire. Each piano key represented a letter of the alphabet and when pressed caused the corresponding letter to print at the receiving end. A shift key gave each main key two optional values. A 56-character type wheel at the sending end was synchronized to coincide with a similar wheel at the receiving end. If the key corresponding to a particular character was pressed at the home station, it actuated the type wheel at the distant station just as the same character moved into the printing position, in a way similar to the daisy wheel printer. It was thus an example of a synchronous data transmission system. House's equipment could transmit around 40 instantly readable words per minute, but was difficult to manufacture in bulk. The printer could copy and print out up to 2,000 words per hour. This invention was first put in operation and exhibited at the Mechanics Institute in New York in 1844. Landline teleprinter operations began in 1849 when a circuit was put in service between Philadelphia and New York City. In 1855, David Edward Hughes introduced an improved machine built on the work of Royal Owl House. In less than 2 years, a number of small telegraph companies, including Western Union in early stages of development, united to form one large corporation. Western Union Telegraph Company appeared to carry on the business of telegraphy on the Hughes system. A Emil Baudot designed a system using a 5-unit code in 1874. The Baudot system was adopted in France in 1877, and later extensively in France. The British Post Office adopted the Baudot system for use on a simplex circuit between London and Paris in 1897, and subsequently made considerable use of duplex Baudot systems on their inland telegraph services. During 1901, Baudot's code was modified by Donald Murray, prompted by his development of a typewriter-like keyboard. The Murray system employed an intermediate step, a keyboard perforator, which allowed an operator to punch a paper tape, and a tape transmitter for sending the message from the punch tape. At the receiving end of the line, a printing mechanism would print on a paper tape, and/or a reperforator could be used to make a perforated copy of the message. As there was no longer a direct correlation between the operator's hand movement and the bits transmitted, there was no concern about arranging the code to minimize operator fatigue, and instead Murray designed the code to minimize wear on the machinery, assigning the code combinations with the fewest punched holes to the most frequently used characters. The Murray code also introduced what became known as format effectors, or control characters, the C and LF codes. A few of Baudot's codes moved to the positions where they have stayed ever since, the null or blank and the del code. Null blank was used as an idle code for when no messages were being sent. In 1902, electrical engineer Frank Pearne approached Joy Morton, head of Morton Salt, seeking a sponsor for research into the practicalities of developing a printing telegraph system. Joy Morton needed to determine whether this was worthwhile and so consulted mechanical engineer Charles L. Crum, who was vice president of the Western Cold Storage Company. Crum was interested in helping Pearne, so space was set up in a laboratory in the attic of Western Cold Storage. Frank Pearne lost interest in the project after a year and left to get involved in teaching. Crum was prepared to continue Pearne's unregistered trademark work, and in August 1903 a patent was filed for a tip bar page printer, unregistered trademark. In 1904, Crum filed a patent for a typewheel printing telegraph machine, unregistered trademark, which was issued in August 1907. In 1906 Charles Crum's son, Howard Crum, joined his father in this work. It was Howard who developed and patented the start-stop synchronizing method for co-telegraph systems, which made possible the practical teleprinter. In 1908, a working teleprinter was produced by the Morecambe Company, called the Morecambe Printing Telegraph, which was field-tested with the Alton Railroad. In 1910, the Morecambe Company designed and installed the first commercial teletypewriter system on postal telegraph company lines between Boston and New York City using the blue code version of the Morecambe Printing Telegraph. In 1916, Edward Kleinschmidt filed a patent application for a tip-bar page printer. In 1919, shortly after the Morecambe Company obtained their patent for a start-stop synchronizing method for co-telegraph systems, which made possible the practical teleprinter, Kleinschmidt filed an application titled Method of and Apparatus for Operating Printing Telegraphs, which included an improved start-stop method. The basic start-stop procedure, however, is much older than the Kleinschmidt and Morecambe inventions. It was already proposed by Delanourt in 1870. Instead of wasting time and money in patent disputes on the start-stop method, Kleinschmidt and the Morecambe Company decided to merge and form the Morecambe-Kleinschmidt Company in 1924. The new company combined the best features of both their machines into a new typewheel printer for which Kleinschmidt, Howard Crum, and Sterling Morton jointly obtained a patent. In 1924 Creed & Company, founded by Frederick G. Creed, entered the teleprinter field with their Model 1P, a page printer, which was soon superseded by the improved Model 2P. In 1925 Creed acquired the patents for Donald Murray's Murray code, a rationalized Baudot code. The Model 3 tape printer, Creed unregistered trademark's first combined start-stop machine, was introduced in 1927 for the Post Office Telegram Service. This machine printed received messages directly onto gummed paper tape at a rate of 65 words per minute. Creed created his first keyboard perforator, which used compressed air to punch the holes. He also created a reperforator and a printer. The reperforator punched incoming Morse signals onto paper tape and the printer decoded this tape to produce alphanumeric characters on plain paper. This was the origin of the Creed high-speed automatic printing system, which could run at an unprecedented 200 words per minute. His system was adopted by the Daily Mail for daily transmission of the newspaper contents. The Creed Model 7-page printing teleprinter was introduced in 1931 and was used for the inland telex service. It worked at a speed of 50 baud, about 66 words a minute, using a code based on the Murray code. A teletype system was installed in the Federal Aviation Administration Flight Service Station Airway Radio Station System in 1928, carrying administrative messages, flight information and weather reports. By 1938, the FAA's teletype network, handling weather traffic, extended over 20,000 miles, covering all 48 states except Maine, New Hampshire, and South Dakota. Ways in which teleprinters were used. There were at least 5 major types of teleprinter networks, exchange systems such as telex and TWX. These created a real-time circuit between two machines, so that anything typed on one machine appeared at the other end immediately. US and UK systems had actual telephone dials, and prior to 1981 5 US area codes were reserved for teletype use. German systems did dialing via the keyboard. Typed chat was possible, but because billing was by connect time, it was common to prepare messages on paper tape and transmit them without pauses for typing. Lease line and radio teletype networks arranged in point-to-point and /or multipoint configurations to support data processing applications for government and industry, such as integrating the accounting, billing, management, production, purchasing, sales, shipping and receiving departments within an organization to speed internal communications. Message switching systems. This was an early form of email, done with electromechanical gear. See Telegram, Western Union, Plan 55A. Military organizations had similar but separate systems. See OTODIN. Broadcast systems such as weather information distribution and news wires. See Associated Press, National Weather Service, Reuters, and United Press. News was received on receive-only teleprinters, without keyboards or dials. Loop systems, where anything typed on any machine on the loop printed on all the machines. Police departments use such systems to interconnect precincts. Teleprinter Operation. Most teleprinters used the 5-bit baud code. This limited the character set to 32 codes. One had to use a fixed shift key to type numbers and special characters. Special versions of teleprinters had fixed characters for specific applications, such as weather symbols for weather reports. Print quality was poor by modern standards. The baud code was used asynchronously with start and stop bits. The asynchronous code design was intimately linked with the start-stop electromechanical design of teleprinters. Other codes, such as ASCII, file data and typewriter, were introduced but never became as popular as baud. Mark and spacer terms describing logic levels in teleprinter circuits. The native mode of communication for a teleprinter is a simple series DC circuit that is interrupted, much as a rotary dial interrupts a telephone signal. The marking condition is when the circuit is closed, the spacing condition is when the circuit is open. The idle condition of the circuit is a continuous marking state, with the start of a character signaled by a start bit, which is always a space. Following the start bit, the character is represented by a fixed number of bits, such as 5 bits in the baud code, each either a mark or a space to denote the specific character or machine function. After the character's bits, the sending machine sends one or more stop bits. The stop bits are marking, so as to be distinct from the subsequent start bit. If the sender has nothing more to send, the line simply remains in the marking state until a later space denotes the start of the next character. The time between characters need not be an integral multiple of a bit time, but it must be at least the minimum number of stop bits required by the receiving machine. When the line is broken, the continuous spacing causes a receiving teleprinter to cycle continuously, even in the absence of stop bits. It prints nothing because the characters received are all zeros, the baud blank null character. Teleprinter circuits were generally leased from a communications common carrier and consisted of twisted pair copper wires through ordinary telephone cables that extended from the teleprinter located at the customer location to the common carrier's central office. These teleprinter circuits were connected to switching equipment at the central office for telex and TWX service. Private line teleprinter circuits were not directly connected to switching equipment. Instead, these private line circuits were connected to network hubs and repeaters configured to provide point-to-point or point-to-multipoint service. More than 2 teleprinters could be connected to the same wire circuit by means of a current loop. Earlier teleprinters had 3 rows of keys and only supported uppercase letters. They used the 5-bit baud code and generally worked at 60 to 100 words per minute. Later teleprinters, specifically the Teletype Model 33, used ASCII code, an innovation that came into widespread use in the 1960s as computers became more widely available. Speed, intended to be roughly comparable to words per minute, is the standard term introduced by Western Union for a mechanical teleprinter data transmission rate using the 5-bit baud code that was popular in the 1940s and for several decades thereafter. Such a machine would send 1 start bit, 5 data bits, and 1.42 stop bits. This unusual stop bit time is actually a rest period to allow the mechanical printing mechanism to synchronize in the event that a garbled signal is received. This is true especially on high-frequency radio circuits where selective fading is present. Selective fading causes the mark signal amplitude to be randomly different from the space signal amplitude. Selective fading, or Rayleigh fading, can cause two carriers to randomly and independently fade to different depths. Since modern computer equipment cannot easily generate 1.42 bits for the stop period, common practice is to either approximate this with 1.5 bits, or to send 2.0 bits while accepting 1.0 bits receiving. For example, a 60-speed machine is geared at 45.5 baud, a 66-speed machine is geared at 50.0 baud, a 75-speed machine is geared at 56.9 baud, a 100-speed machine is geared at 74.2 baud, and a 133-speed machine is geared at 100.0 baud. 60-speed became the de facto standard for amateur radio RTTY operation because of the widespread availability of equipment at that speed and the U.S. Federal Communications Commission restrictions to only 60 speed from 1953 to 1972. Telex, news agency wires and similar services commonly used 66-speed services. There was some migration to 75 and 100 speed as more reliable devices were introduced. However, the limitations of HF transmissions such as excessive error rates due to multipath distortion and the nature of ionospheric propagation kept many users at 60 and 66 speed. Most teletype audio recordings in existence today are of teleprinters operating at 60 words per minute, and mostly of the Teletype Model 15. Another measure of the speed of a teletype machine was in total operations per minute. For example, 60 speed was usually 368 OPM, 66 speed was 404 OPM, 75 speed was 460 OPM, and 100 speed was 600 OPM. Western Union telexes were usually set at 390 OPM, with 7.0 total bits instead of the customary 7.42 bits. Both wire service and private teleprinters had bells to signal important incoming messages and could ring 24/7 while the power was turned on. For example, ringing 4 bells on UPI wire service machines meant an urgent message. 5 bells was a bulletin. And 10 bells was a flash, used only for very important news, such as the assassination of John F. Kennedy. The teleprinter circuit was often linked to a 5-bit paper tape punch and reader, allowing messages received to be resent on another circuit. Complex military and commercial communications networks were built using this technology. Message centers had rows of teleprinters and large racks for paper tapes awaiting transmission. Skilled operators could read the priority code from the whole pattern and might even feed a flash priority tape into a reader while it was still coming out of the punch. Routine traffic often had to wait hours for relay. Many teleprinters had built-in paper tape readers and punches, allowing messages to be saved in machine-readable form and edited offline. Communication by radio, RTTY, was also common. Amateur radio operators continue to use this mode of communication today. Control characters equals. A typewriter or electromechanical printer can print characters on paper, and execute operations such as move the carriage back to the left margin of the same line, advance to the same column of the next line, and so on. Commands to control non-printing operations were transmitted in exactly the same way as printable characters by sending control characters with defined functions to teleprinters. In modern computing and communications, a few control characters, such as carriage return and line feed, have retained their original functions, but many others are no longer required and are used for other purposes. Here is key equals. Some teleprinters had a here is key, which transmitted a fixed sequence 20 or 22 characters, programmable by breaking tabs off a drum. This sequence could also be transmitted automatically upon receipt of an ENQ signal, if enabled. This was commonly used to identify a station. The operator could press the key to send the station identifier to the other end, or the remote station could trigger its transmission by sending the ENQ character, essentially asking, "Who are you?" Manufacturers. Creed and Company Creed and Company, a British company, built teleprinters for the GPO's teleprinter service. Creed Model 7E, Creed Model 7B, Creed Model 7, Creed Model 7/RP, Creed Model 54, Creed Model 75, Creed Model 85, Creed Model 86, Creed Model 444. Kleinschmidt Labs In 1931 Edward Kleinschmidt formed Kleinschmidt Labs to pursue a different type design of teletype. In 1944 Kleinschmidt demonstrated their lightweight unit to the Signal Corps, and in 1949 their design was adopted for the Army's portable needs. In 1956 Kleinschmidt Labs merged with Smith Corona, which then merged with a Marchant Calculating Machine Company, forming the SCM Corporation. By 1979 the Kleinschmidt division was branching off into electronic data interchange, a business in which they became very successful, and replaced the mechanical products, including teleprinters. Kleinschmidt machines, with the military as their primary customer, used standard military designations for their machines. The teleprinter was identified with designations such as a TT4/FG, while communication sets to which a teleprinter might be a part generally used the standard Army-Navy designation system such as ANFGC-25. This includes Kleinschmidt Teleprinter TT117/FG and tape perforator TT179/FG. Markram made their first commercial installation of a printing telegraph with the Postal Telegraph Company in Boston and New York in 1910. It became popular with railroads, and the Associated Press adopted it in 1914 for their wire service. Markram merged with their competitor Kleinschmidt Electric Company to become Markram-Kleinschmidt Corporation shortly before being renamed the Teletype Corporation. Olivetti Italian office equipment maker Olivetti started to manufacture teleprinters in order to provide Italian post offices with modern equipment to send and receive telegrams. The first models typed on a paper ribbon, which was then cut and glued into telegram forms. Olivetti T1, Olivetti T2, Olivetti TE300, Olivetti TE400. Siemens and Halske Siemens and Halske, later Siemens AG, a German company, founded in 1897. Teleprinter Model 100 SER 1 €, used for telex service. Teleprinter Model 100 SER 11 €, later version with minor changes. Teleprinter Model T100 ND/NDL models. Teleprinter Model T150, offline tape punch for creating messages. Teleprinter T1000 electronic teleprinter 50-75-100 BD. Tape punch and reader attachments and DSEUV21 modem model. Teleprinter T1000 receive-only units as used by newsrooms for unedited SAPUP feeds etc. Teleprinter T1200 electronic teleprinter 50-75-100-200 BD green LED text display, 1.44 m 3.5 inches floppy disk attachment, PC telex teleprinter with dedicated dot matrix printer connected to IBM compatible PC. T4200 teletext teleprinter with 2 floppy disk drives and black and white monitored daisy wheel typewriter. Teletype Corporation The Teletype Corporation, a part of American Telephone and Telegraph Company's Western Electric manufacturing arms since 1930, was originally founded in 1906 as the Markram Company. In 1925, a merger between Markram and Kleinschmidt Electric Company created the Markram-Kleinschmidt Company. The name was changed in December 1928 to Teletype Corporation. In 1930, Teletype Corporation was purchased by the American Telephone and Telegraph Company and became a subsidiary of Western Electric. In 1984, the divestiture of the Bell system resulted in the Teletype name and logo being replaced by the AT&T name and logo, eventually resulting in the brand being extinguished. The last vestiges of what had been the Teletype Corporation ceased in 1990, bringing to a close the dedicated teleprinter business. Despite its long-lasting trademark status, the word teletype went into common generic usage in the news and telecommunications industries. Records of the United States Patent and Trademark Office indicate the trademark has expired and is considered dead. Teletype machines tended to be large, heavy, and extremely robust, capable of running non-stop for months at a time if properly lubricated. The Model 15 stands out as one of a few machines that remained in production for many years. It was introduced in 1930 and remained in production until 1963, a total of 33 years of continuous production. Very few complex machines can match that record. The production run was stretched somewhat by World War II. The Model 28 was scheduled to replace the Model 15 in the mid-1940s, but Teletype built so many factories to produce the Model 15 during World War II, it was more economical to continue mass production of the Model 15. The Model 15, in its receive-only, no keyboard, version was the classic news teletype for decades. Model 28 equals board. Version, 45-50-56-75 board, optional tape punch and reader. Model 32 equals small lightweight machine 45-50-56-75 board, optional tape punch and reader. Model 33 equals same as Model 32 but for 8-level ASCII plus parity bit, used as computer terminal, optional tape punch and reader. Model 35 equals same as Model 28 but for 8-level ASCII plus parity bit, used as heavy-duty computer terminal, optional tape punch and reader. Model 37 equals improved version of the Model 35, higher speeds up to 150 board, optional tape punch and reader. Model 38 equals similar to Model 33, but for 132 char. /line paper, optional tape punch and reader. Model 40 equals new system processor based, with monitor screen, but mechanical chain printer. Model 42 equals new cheap production board. Machine to replace Model 28 and Model 32, paper tape pack. Model 43 equals same but for 8-level ASCII plus parity bit, to replace Model 33 and Model 35, paper tape pack. Several different high-speed printers like the Inktronic etc. Telex. A global teleprinter network, called the Telex network, was developed in the late 1920s, and was used through most of the 20th century for business communications. The main difference from a standard teleprinter is that Telex includes a switched routing network, originally based on pulse telephone dialing, which in the United States was provided by Western Union. AT&T developed a competing network called TWX, which initially also used rotary dialing and baud code, carried to the customer premises as pulses of DC on a metallic copper pair. TWX later added a second ASCII-based service using Bell 103 type modems served over lines whose physical interface was identical to regular telephone lines. In many cases, the TWX service was provided by the same telephone central office that handled voice calls, using class of service to prevent POTS customers from connecting to TWX customers. Telex is still in use in some countries for certain applications such as shipping, news, weather reporting and military command. Many business applications have moved to the Internet as most countries have discontinued Telex TWX services. Teletype setter, in addition to the 5-bit baud code and the much later 7-bit ASCII code, there was a 6-bit code known as the TTS code used by newswire services. Through the use of shift-in and shift-out codes, this 6-bit code could represent a full set of upper and lowercase characters, digits, symbols commonly used in newspapers, and limited typesetting instructions such as flush left or center. A Model 20 teletype machine with a punch was installed at subscriber newspaper sites. Originally these machines would simply punch paper tapes and these tapes would be read by a tape reader attached to a linotype machine, creating type for printing in newspapers and magazines. In later years the incoming 6-bit current loop signal was coupled directly into a minicomputer or mainframe for storage, editing, and eventual feed to a phototype setting machine. Teleprinters in computing. Computers used teleprinters for input and output from the early days of computing. Punched card readers and fast printers replaced teleprinters for most purposes, but teleprinters continued to be used as interactive time-sharing terminals until video displays became widely available in the late 1970s. Users typed commands after a prompt character was printed. Printing was unidirectional. If the user wanted to delete what had been typed, further characters were printed to indicate that previous text had been cancelled. When video displays first became available, the user interface was initially exactly the same as for an electromechanical printer. Expensive and scarce video terminals could be used interchangeably with teleprinters. This was the origin of the text terminal in the command line interface. Paper tape was sometimes used to prepare input for the computer session offline and to capture computer output. The popular Teletype Model 33 used 7-bit ASCII code instead of baudot. The common modem communications settings, start-stop bits and parity, stem from the teletype era. In early operating systems such as Digital's RT11, serial communication lines were often connected to teleprinters and were given device names starting with TT. This and similar conventions were adopted by many other operating systems. Unix and Unix-like operating systems use the prefix TTY, for example TTY13, or PTY, such as FTOO. In many computing contexts, TTY has become the name for any text terminal, such as an external console device, a user dialing into the system on a modem on a serial port device, a printing or graphical computer terminal on a computer's serial port, or the RS-232 port on a USB to RS-232 converter attached to a computer's USB port, or even a terminal emulator application in the Windows system using a pseudo-terminal device. Teleprinters were also used to record fault printout and other information in some TXE telephone exchanges. Obsolescence of teleprinters. Although printing news, messages, and other text at a distance is still universal, the dedicated teleprinter tied to a pair of leased copper wires was made functionally obsolete by the fax, personal computer, inkjet printer, broadband, and the Internet. In the 1980s, packet radio became the most common form of digital communications used in amateur radio. Soon, advanced multimode electronic interfaces such as the AEA Park 232 were developed, which could send and receive not only packet, but various other modulation types including baudot. This made it possible for a home or laptop computer to replace teleprinters, saving money, complexity, space and the massive amount of paper which mechanical machines used. As a result, by the mid-1990s, amateur use of actual teletype machines had waned, though a core of purists still operate on equipment originally manufactured in the 1940s, 1950s, 1960s and 1970s. Despite the obsolescence of teleprinters by the 21st century, its distinctive sound continues to be played in the background of newscasts on the New York City radio station WINS, a tradition dating back to the mid-1960s. See also, letter quality printer, Plan 55, a message switching system for telegrams. Radio teletype, Siemens and Halsk T52 the Geheimfernschreiber. References. Further reading, Teletype messages sent through switchboard, Popular Mechanics, April 1932. AT&T offering two-way service through switchboards, A.G. Hobbs, G8GOJ. E.W. Manson, G3IIR, ACG, G2 UK. Teleprinter Handbook. RSGB ISBN 0-900612-59-2. Foster, Maximilian. A Successful Printing Telegraph. The World's Work 2, 1195 €1200. Retrieved April 29, 2012. Gannon, Paul. Colossus, Bletchley Park's Greatest Secret. London. ISBN 978-1843543,312. On the Role of the Teleprinter Code in WWII. External links, a first-hand report of Teletype Corporation's early years, a gallery of teletype images, history of teletypewriter development by R. A. Nelson, Some notes on Teletype Corporation, mass.gov, TTY explanation and government best practices for TTY use. Patents U.S. Patent 1,665,594 Telegraph Printer, filed June 1924, issued April 1928, U.S. Patent 1,745,633 Telegraph Receiver, filed December 1924, issued February 1930, U.S. Patent 1,904,164 Signaling System and Apparatus therefore a Euro filed July 1930, issued April 1933, U.S. Patent 3,507,997 Frequency Shift Teletypewriter a Euro filed August 1966, issued April 1970.